Hello everyone, welcome to all 12 science student. Myself M.A. Wasave, Department of Chemistry, HDSM College, Junior College, Palghar. Subject Chemistry, Chapter number 1, Solid State. Introduction. In introduction, you have to simply study earlier that the solid state of matter is characterized by strong interparticle forces of attraction. As a result, most of solids have definite shape and volume. Next, which change only slightly with change in temperature and pressure. The smallest constituent particles of various solids are atoms, ions, or molecules. All such smallest constituent particles of solid will be referred as particles in the chapter. Simple, we know that what is the solid, liquid and gases is the three state of matter. These three state of matter is simply interconvertible, that is when you have to heat it, the solid is converted into liquid, liquid is converted into gases. Again you have to repeat, is remove the heat, then gas is converted into liquid and liquid is converted into solid. Simple in the chapter last year you have to study that is liquid state and gaseous state. This year you have to study it by detail solid state. Then in solid state, some of the part will be reduced by government of Maharashtra due to COVID-19. That is 20% part will be reduced. Simple, in between this crystalline substance and amorphous substance part will be reduced. Next part, that is isomorphism and polymorphism. Simple, in this concept, similarity or dissimilarities of crystal structure of different solids is described as isomorphism and polymorphism. First one, isomorphism. Two or more substances having same crystal structure are said to be isomorphous. In this substance, the chemical composition has the same atomic ratio. For example, NaF and MgO. Second one, NaNO3 and CaCO3 are isomorphous pairs and have the same atomic ratio, that is 1:1 and 1:1:3 respectively of the constituent atom. In simple, isomorphous means what? That is the two or more substances having same crystal structure. For example, NF and MgO, that is 1:1 atomic ratio. Next one, that is polymorphism. In polymorphism, we have to simply study that. That is a single substance that exists in two or more forms or crystalline structures is said to be polymorphous, or a substance are formed under different conditions. For example, calciate and argonides are the form of calcium carbonate, that is alpha cortege, beta cortege and crystallobalites are three forms of silica. And also this polymorphism is known as allotropic forms of same substance. Means simple, for example, diamonds, graphites and fullerenes are the three allotropic forms of carbon. In this figure you have to show that is the structure of diamond and graphites. Then next one, that is classification of crystalline solids. In classification of crystalline solids are further classified into four categories. First, ionic solid, second one, covalent network solids, next one, molecular solids, and next one is metallic solids. First one, ionic solids. In ionic solids or ionic crystals have the following characteristic properties. First, the constituent particles of ions, ionic crystals are charges ion, that is cations and anions. It's having different size. Next property, that is each ions of a given sign of charge is bonded to ions of opposite charge around it by Coulomb forces. Next one, in other words, you have to simply say that the particles of ionic crystals are held by electrostatic force of attraction between oppositely charges ions. Next one, next property, that is ionic crystals are hard and brittle. They have also high melting points. Next property, that is these are non-conductors of electricity in solid state, but however they are good conductors when melted or dissolved in water. For example, NaCl, K2SO4, Kf2, KCl are ionic crystals. This simple diagram shows what is the structure of NaCl, what is the intermolecular forces is there. It's having positive and negative ions, and these, with the help of these positive and negative ions, which are attract to each other and held together by electrostatic force of attraction. Next one, that is covalent network crystal. This characteristic of covalent network crystals is as first one, that is the constituent particles in covalent network crystals solids are atoms. The atoms in these crystals are linked by continuous systems of covalent bond. The result is a rigid three-dimensional network that forms a Gantt molecule. The entire crystal is a single molecule. Next one, as a result of rigid and strongly bonded structure, covalent network crystals are very hard. In fact, they are the hardest and most incompressible of all the materials. These crystals have high melting point and boiling points. For example, diamond, potash, silicon, that is SiO2, boron nitrides are covalent network solids. This diagram will be simply shows what is the covalent bond and covalent network diagrams. You have to simply observe and understood. Next one, that is molecular crystals. Substances such as Cl2, CH4, H2, CO2, O2 on solidification give molecular crystal. Crystalline organic compounds are also molecular crystals or solids. The bonds within the molecules are covalent. The molecules are held together by various intermolecular forces of attractions in molecular crystals. Then you have to simply observe, for example, that is different types of intermolecular forces is there, that is weak dipole-dipole interaction. We also know that that type of concept you have to study in L1 science, that is gaseous state. In polar molecules, that is weak dipole-dipole interactions. In these polar molecules such as solid hydrochloric acid, water, SO2, which possesses permanent dipole moments. Then next one, that is very weak dispersion, or that is the London forces. In polar molecule such as solid CH4, H2, these forces are also involved in monoatomic solids like argon, neon. These substances are usually gases at room temperature. Next one, that is intermolecular hydrogen bonding. In such a solid as water molecule, that's like ice, NH3, ammonia, and hydrofluoric, as a intermolecular hydrogen bonding structure will be shows. These molecular crystals are simply understood by it's having weak intermolecular force of attractions and hydrogen bonding. That type of different forces of attractions are present. Because of weak intermolecular attractive forces, molecular solids are usually soft substances with low melting points. Simple, this structure will be observed, that is the molecular crystals. Next, that is metallic crystals. These are crystalline solids formed by atoms of the same metallic element held together by a metallic bond. Metallic bond is the concept of in a solid metal, the valence electrons are delocalized over the entire crystal, leaving behind positive charges, metals, ions. Therefore, metallic crystals are often described as an array of positive ions immersed in a sea of mobile electrons. The attractive interaction between cations and mobile electrons constituent of the metallic bonds. Metals are these metallic crystals are also having malleability, that is malleable, means they can be hung into thin sheets. When you have to humming, then you have to prepare by thin sheets from these metals. Also, these metals having ductility, that is they can be drawn into wires when you have to high heating, after heating which is converted into wires. Next one, these are the good conductors of electricity and thermal conductivities. Next one, the metals such as sodium, potassium, calcium, lithium, ferrous, gold, silver and cobalt etc. are the examples of metallic crystals. Next one, simple this diagram you have to simple explain this second point, that is metallic bonds. The bonds having positive, negative, positive, positive, negative, negatives are present, and these all electrons are moving or delocalized surrounding these positive or negative charges. Okay, understood? Okay, next one, that is in this one table is prepared, is this table you have to totally summaries will be described, you have to observe and study. Simple one, these properties of four types of crystal. In this row and columns I will write down, that is the ionic solid, that is types of solids: ionic solid, covalent solids, molecular solids and metallic solids. In properties, first one, that is the पार्टिकल्स ऑफ यूनिट सेल. सेकंड, पार्टिकल्स ऑफ यूनिट सेल में हम लोग क्या डिस्क्राइब कर सकते हैं, दैट इज cations and anions is there in ionic solid. In covalent solid, that is covalently bonded atoms is there. And molecular solids, that is monoatomic or polyatomic molecules are there. And metallic solids, you have to simply observe, that is the metallic ions are in a sea of electrons. Second property, interparticles forces. Here electrostatic force is there, here covalent bondage force is there, here London force, dipole force and these hydrogen bonding forces are there, which are simple you have to explain in point wise. Here only simply summary is there. That is the last one, is metallic bondage of attraction between the cations and mobile electron, valence electrons is there. Third property, hardness. Hardness means simple here, that is hard and bright beetle. These are very hard, that is soft, and these are the variable from soft and very hard. Here melting points is also high, very high, here high, that is up to 600 to 3000. Next one is also high, that is 1200 to 4000, and that is low, minus 272 degrees Celsius to 400 degrees Celsius. There is also wide range, that is minus 39 degrees Celsius to 3400 degrees Celsius. And last one is that thermal and electrical conductivity. Here that is the poor electrical conductors, these are also poor electrical conductors, these are also poor electrical conductors, and last one is the good electrical conductors of heat and electricity. Okay, these are simple, all these four types of metallic solids are summarized. After this you have to study, that is crystal structure. क्रिस्टल स्ट्रक्चर में हम लोग को ये पढ़ना है कि द ऑर्डर थ्री डायमेंशनल अरेंजमेंट ऑफ पार्टिकल्स इन अ क्रिस्टल is described using two terms, that is lattice point and basis point. Simple one, here you have to observe, that is the crystal lattice and basis. What is the concept of this? This lattice is a geometrical arrangement of point in three-dimensional periodic array, that's like, and a crystal structure is a obtained by attaching a constituent particles to each of the lattice point. Such constituent particles that are attached to the lattice point from the basis of crystal lattice. Crystal is also called space lattice of crystal. Thus, crystals is the structure of results by attaching the basis of each of the lattice point. It is represented by the following equation. Just like these are the lattice and these are the bases. These combine to each other, it gives crystals. Okay. After this, next one, unit cell. Unit cell is the most important to our board exam. What is the definition of unit cell? That is the smallest repeating structure or structural unit of crystalline is called as unit cell. In this point, you have to simply understood the space lattice of a crystal is built of a three-dimensional basis pattern. This basis pattern is repeated in dimensions to generate the entire crystal. Second point, when the unit cell are stocked together or attached together to generate the crystal, each unit cell share its faces, edges and corners with neighboring unit cell. It is important to understand that the geometric shape of unit cell is same as that of the macroscopic crystal. For example, if the crystal has cubic shape, the unit cell will also have its constituent particles arranged to form a tiny cube. Next point, that is the dimension of unit cell along the three axes are denoted by a symbol A, B and C. The angle between these axes are represented by the symbol alpha, beta and gamma shown in this next figure. That is these angles between them, alpha, beta and gamma, and this or the length is A, B and C is there. Okay. Next one, types of unit cell. There are four types of unit cell. First one, types of unit cell. First unit cell is primitive or simple unit cells. In primitive unit cell or simple unit cell or simple cubic unit cell, the constituent particles are present at its corner only. Second one, body center cubic unit cell. In this type of unit cell, one constituent particle is present at the center of its body and all the 8 particles are present in 8 corners. Third one, face-centered cubic unit cell. This unit cell consists of particle at the center of each of the face in addition to the corner particles. Means simple, all the 6 faces having half particles and 1 particles are all the 8 corners. Last one, that is base center unit cell. In base center unit cell consist the particles at the center of any two of its opposite faces, that is top and bottom parts. Simple. This diagram will be understood, that is primitive, body center and face center. In primitive you have to simply show that is all 8 particles are present in the 8 corners. In body centers, all these 8 corners plus 1 body center particles means total number of 2 particles. In these face center, all these 6 faces having half of parts and these 8 corners having 1 particles. Total number of 4 particles is present. Next one, crystal system. By mathematical analysis, it has been proved that only 14 different kinds of space lattice are possible, or 14 ways in which similar points can be arranged in the three-dimensional order. These 14 lattice which describe the crystal structure are called Bravais lattice. Next, in 14 Bravais lattice are divided into 7 main types of crystal systems. The possible combination of lattice point space or spacing is indicated by A, B and C along the 3 axes, and the angle between them is alpha, beta and gamma. Between these axes give rise to 7 crystal systems. These 7 crystal systems are associated with 14 Bravais lattice, also called 14 unit cell. This diagram simply you have to observe, that is the 7 types of main types of crystal system. That is, first one is cubic, second one is tetrahedral, then orthorhombic, monoclinic, triclinic and rhombohedral. Last one is hexagonal. Simple, here you have to main observing point is that is the edges is A, B and C, and angle between them, that is alpha, beta and gamma. These main points you have to simply divided into 7 types of unit cells. Next one, cubic crystal system. There are 3 types of unit cell in cubic crystal system, same as last time, that is SCC, BCC and FCC. Means simple, primitive or simple cubic system, body center cubic system and face center cubic unit cell. First one, simple cubic unit cell, that is it has a particle at each of the 8 corners of the cube. We know that. The last point you have to simply explain. Means all the 8 points are present in the 8 corners. Second one, body center, same as last point, that is also 8 particles are present in the 8 corners and 1 particles are present in the center of the body. Is total number of 2 atoms. Then next one, that is face center cubic unit cell, also same as face center, or the faces having half of parts and all the 8 corners having 1 particle. Total number of 4 particles are present in the FCC. Then this, observe what is the simple cubic, face center cubic and body center cubic unit cell. What the diagram will be indicated by this. It's simple, having 8 corners, 8 particle, 8 half 1 by 8 into 8 is equal to 1 particles, and body centers 1 center, and all the 8 parts is 1 plus 1 is equal to 2 particles, and phase center is equal to 1 half into 6 plus 1 is equal to 4 particles are present in the FCC. Next one, this number of particles in cubic unit cells. Here also primitive or simple cubic unit cells. A simple cubic unit cell has the particle at its 8 corners. When these unit cells are attached together, the particle at each corner of a given unit cell is shared with 7 others, a simple neighboring cubes that comes together at the corners. As a result, the corner particles contributes its 1 by 8 parts of the given unit cells. Thus, a simple cubic unit cell has 1 upon 8 into 8 is equal to 1 particles per unit cell is present. These simple one, these 8 particles having 8 particles means 8 particles, 1 particles are attached to another 7 point. These having 1 by 8 into 8, that is equal to 1 particles per unit cells. Next one, body center cubic unit cell. Number of particles having body center cubic unit cell. A BCC unit cell has 8 corners particles and one of the additional particles at the center of the body of the cube, and that is equal to 1 by 8 into 8 is equal to 1 plus 1 is the body center atoms is equal to 2, total number of 2 atoms. Next one, the particles at that the center of a given cube is not shared by any other cubes. Thus, BCC unit cell has 1 particles from 8 corners plus 1 particles in the center of the cube. Total number of particles is equal to 2 particles are per unit cells are present in the body center cubic unit cells. Okay. Next, this example simple. This diagram will be simply as this 1 by 8 from 8 corners, and these 1 atoms are present in the center of the cube. That is total number of 2 particles are present. Understood? Next one. That is phase center cubic unit cells. Number of particles are how much number of particles are present in phase center cubic unit cell. FCC unit cell has particles at the 8 corners plus particles at the center of its 6 faces. As described in simple cubic unit cell, 1 particles from 8 corners belong to the given unit cell, and each particle at the center of 6 faces is shared with 1 neighboring cube. Means that is 1 half. Thus, 1 half of each faces particles belong to the given unit cells. Means from 6 faces, that is 1 by 8 into 6 is equal to 3. Total number of 3 particles belongs to the given unit cells. Then total number of particles equal, therefore the FCC unit cells has 1 plus 1 plus 3 is equal to 4 particles per unit cells. This diagram will be simple. Understood that 1 half is all 6 faces and 1 by 8 is all 8 corners. Total number of 4 particles are present in FCC unit cell, phase center cubic unit cells. One, that is relation between molar masses, density of the substances, and unit cell, its edge length, and deduce in the following steps. First step, if edge length of cubic unit cell is A, suppose edge length of cubic unit cell is A, then the volume of unit cell is equal to A cube. Okay. Then suppose that the mass of one particles is small m, and that is there are n number of particles is per unit cell is there. Simple. When m particles, suppose mass is m particle, mass of one particle is m, then at that time these all constituent are n particle per unit cells. Okay, is it is that simple? You have to equation mass of unit cell is equal to m into n, that is equation number 1. Next one, the density of unit cell rho, which is same as density of substance, is given by rho is equal to mass of unit cell divided by volume of unit cells is equal to m into n upon a cube is equal to density of the substance. Next one, continue to point number 4, molar mass m. Suppose molar mass is m, you have to consider of the substance, given substances. Then m is equal to mass of one particles into number of particles per moles, that is m into small m into n. Means capital M is equal to small m into Na. Na is the number of particles per mole, that is Avogadro's number. Therefore, when you have to calculate by small m, capital M is equal to m into Na. अगर हम लोग को स्मॉल m कैलकुलेट करना है तो m इज इक्वल टू स्मॉल m इज इक्वल टू कैपिटल M upon Na, that is Avogadro's number. Then these all equation number 1 and equation number 3 you have to combine to each other. After this you have to we get that this rho is equal to n into m upon a cube into Na. These are the final equations. By knowing any 4 parameters from equation number 4, then you have to calculate by fifth one easily. ठीक है.